Is Elaine Vehar. I go by Silvani, and this is my presentation for my final project for Introduction to Data Mining and Machine Learning, Spring 2022. And the title of my project is Classification of Fetal State. And before I tell you a little bit about my code, I want to tell you a little bit about the data and why I chose this data. So this is a data set, and I got this from the University of California, Irvine. And this data is data recorded from cardiotocograms, which are basically assessments, measurements that are recorded from pregnant women during the third trimester to monitor the well-being of unborn babies. So, and I wanted to know more about this data because on a personal note, when I had my daughter 3.5 years ago, I went to a routine check and I got one of these exams done, and it was discovered that my daughter was actually having some distress, and I ended up having to have an emergency C-section. And so thankfully, this did what it was supposed to do. It assessed all the risks for my baby quite well. So I wanted to learn a little bit more about the data. So the data that this file contained are all these different variables. Now, I didn't use all these variables that are shown here, and I'm going to I used some of them, but not all of them. But this was the original data, and the raw data that I actually used was this data right here. So you can see there are tons of things. I think there are 40 different columns and approximately a little bit over 2,000 observations. Okay, so now let me start telling you a little bit about the code and the different methods that I chose to do. So just to summarize, right, I used this, and I actually used it to classify, I don't think I was clear about that, to classify the fetal state. So the fetal state right here, this is what I was hoping to classify. So it's either 1 for normal, 2 for suspect, and 3 for pathologic. So that was my goal for this particular project. So now let's start looking at the code. Actually, before I look at the code, let's talk about the machine learning algorithm. So I kind of used this cheat sheet. I found it quite helpful in helping me decide which algorithms I wanted to use. So when I look at this, I was like, okay, what am I doing? I am definitely using a classification algorithm. So I wanted to try something that was unsupervised and something that was supervised. So k-means, it's something that I think we did in class. So it seemed like I wanted to do that. So I used that, and I also wanted to look at, I did linear SVM, and I also did random forest. Because they were well in some of the projects that we did in class, some of the assignments, so I wanted to try those. So now let's start looking at my code. So I did mention that the data is composed of 2,126 cardiotocograms exactly, and there are 40 different diagnostic features for that. So I'm going to walk you through my project and sort of what I thought I did well, and some of the challenges that I faced, and some of the things that I wish I would have done a little bit differently. So this is just summarizing, looking at the data. Nothing too important, nothing too crazy to see here. But so when I looked at the data, one of the things that I noticed that it was nice for this data set is that there were no missing values. So here, right here, with this plot, I was trying different plots, trying to use different functions that would allow me to learn a little bit more about R, but also that would help me in identifying important information about my data. So this was it. So there was nothing interesting there. This was a distribution of some of the data. So when I looked at this, this helped me figure out 2 important things here. LB and LBE, I noticed that these 2 are basically similar, and they are because one is basically the information obtained from the actual exam, and then the other one is information provided by doctors. So what they did is they took this information and then all this from these exams, and they also got the expertise from 3 different obstetricians, and they came to a consensus in identifying the fetal state. So now I did that twice for some reason, and then here this is just a way that I use to verify that LBE and LB actually are pretty much identical. So I did remove one of those variables because I wanted to avoid some overfitting. So when this was just looking at some normality plots, correlation, when it came to correlation, I was kind of running out of time, and I could have done this in a little bit probably in a better way, because the way that I did my correlation plot, it was just like way too large, way too big. There's really, it's so hard to see that it's not very helpful. Then here I did also correlation plot for the continuous variables, and then another one for the discrete variables. So this is the one that I did for the continuous variables. This for the discrete variables. This for the continuous variables. Most of the so when I look at this, right, even just splitting it down to numeric and to continuous and discrete, it's still quite difficult to see. So I removed so this is where the interesting stuff happens. Always looking at k-means. So after I did some data cleaning, I removed some of the variables that I wasn't going to use for the k-means. I was trying to figure out, what is a good how many number of clusters I should use. So I built my model, and this is one of the things that I got using the FVF, this cluster plot. And when you look at this, the information that I gathered from this plot was that the clusters are not well defined. So if we look at, cluster 1 and 3 are nicely defined, but 1 and 2 are really overlapping a lot with cluster 1. So as soon as I saw this, I thought that this was going to give me poor results, just because each cluster is not clearly defined. And I was right. So when I looked at the results for this particular plot, so let me just look at this. Where is that? So the predictions, I did some predictions right here. We can look at that more in detail. I plotted different things. Now here, the majority of the classifications are in the real data set are 1. So the majority of exams actually tend to be normal, and there are very few that are considered as 3 or classified as 2. So the majority are normal, and which we hope that's the case, right? When we hope that the majority of babies are doing well at the end of the pregnancy, towards the end of the pregnancy. But when we look at this, right, this does not really look great in terms of looking at the accuracy of the model. The accuracy of the model was quite poor. So the success of the prediction that I got was 36.87%. So that was pretty poor. So after doing that, I wanted to try different things to improve my model. And some of the things that I did was I did some bootstrapping right here to just change some things, some of the clusters, and looked at different ways to improve the model. So after using bootstrapping to evaluate my model, I was able to improve that to 69.67%. Now, this reminds me, one of the things that I wish I would have done better with this is that when I did my training set and my test set, I did not set a seed. So every time I am running my code, I get slightly different results. But the results, the accuracy for each model does vary a little bit. But the performance I'll tell you towards the end, but the random forest actually tends to be the best each time, even though the accuracy of each model varies slightly. Okay, so this is not quite helpful, I think. So the next model that I did was the SVM model. Now, with the S support vector machine, it's a relatively simple vector machine, so I wanted to try this out to see how it would work out, and I think this was a really good choice. when we look at this mean versus variance, I think there's another plot that I actually like better. I think this plot I like better in terms of the classification plot, because when this is the variance, right, and we say that the variance, there's not a lot, I guess, a lot of variance in terms of each different classification for the for NSP, which is the fetal state. So this seemed to work quite well. So when I looked at this model right here came out to be 88.65%. And again, here I didn't set a seed, so this changed slightly. But this is what I got initially when I built my model for the SVM. Then I did, let me just see. Okay, so the SVM, let me just see what else I did. So I did some tuning for this model as well, just to see if I could improve the performance of this model. So when I looked at this, what I did, like, it didn't really work that well. The accuracy is still 88.65%. So the tuning that I didn't really help that much. It wasn't really helpful. So the next thing that I did is let me just see. All right, so I did another tuning method. I'm sorry, let me just make this a little bit bigger. And again, so the accuracy is still pretty same. So that didn't really change much. Now, so I used a different method right here also to evaluate the model, right? And towards the end, I have all the different methods that I use for the model, just to see which one would be better. And there is, so the accuracy. So this one right here is actually, I think it was like the best one that worked for the model. So where is the one that I want to show you? Okay, right here. So these are all the different methods that I just showed you. So the linear, twin linear, polynomial, and radial basis. And the radial basis turned out to be the most favorable outcome when trying the different SVM models. So then next one, it was the random forest. And for random forest, this one, I chose this one because it was a relatively simple method model to implement. The training was relatively easy as well. So I thought I would use this, and it actually turned out to be really good too. It worked out really well. So when we looked at this graph, I put it, but I wasn't sure how to interpret this graph too well. So there's a lot of things that I tried, and I had difficulty quite understanding all the different features that each model has. I found that to be a little bit overwhelming, but something that I'm still working to do that. So this right here, the Genie, there is a way to figure out which variables are actually the most useful or least useful, you can say. In comparison, you can say what variable contributes to the model the most. So I was trying to figure that out. Then I do the predicted values. I use in a k-folds also. And this right here turned out to be the best one. So the accuracy was 95.56. So that was my best model to use. And these are out of the 21 variables that I used, these were the 20 most important variables for this particular model. So let me just get to the end, because I think this is just some graphs for the model comparison. In terms of the model comparison, see right here, this changed a little bit. I had a for loop to try to summarize and compare the 3 different models, and this changed slightly because I did not use a set seed. So, but here we can clearly see that the random forest is much more accurate. So it's 95.5%. Second comes SVM, 93%. And K-means is at 55%. I think before I had it at 67%. So it actually went down a little bit. Something else that I didn't get a chance to do for this project was I didn't get to really look at my outliers. Initially I was like, okay, that's something easy that I can do at any time, and I just ran out of time, so I didn't go back, and I just, the way that I evaluated the outliers was just looking at maybe the distribution of the variables that I was looking at. I was thinking, like, are they normal, not normal? Like maybe I was looking at the normality plot to see if the data is skewed or not skewed. In addition, something that I wish I would have done better was the ensemble. That's something that I feel I was still having difficulty understanding the concept of it, so I was not able to implement that for this particular project. So I think overall I was able to efficiently and accurately classify the fetal state of this data set, which is really exciting. And I was able to apply a lot of the concepts that we learned in class. And that is it. If you have any questions, you can always shoot me an email. Thank you.